We will start with naming covalent bonds. So, covalent bonds in covalent naming is also going to be known as molecular naming. Okay. So, the element that comes first is always going to be your less electronegative atom. Okay. And in all binary naming, you're gonna get rid of the end and replace it with IDE. You will not use mono unless with the first element. You usually only use mono with oxide. I don't know why that note is before learning the prefixes, but whatever. All right. So the way that covalent bonding works is that your prefix tells you your subscript, which tells you how many atoms you have. Okay? So 1 is going to be mono. 2 is going to be bi. Think bicycle, right? 3 is going to be tri. Think tricycles have 3 wheels. 4 is going to be tetra. The way that you can remember that is you've learned about tetrahedrals, right? And tetrahedrals have 4 atoms around a central atom. Yep. 5 is going to be penta for pentagon, pentagram, Pentecost. 6 is going to be hexa, which is hectagon. 7 is going to be hepta. Fun fact, September used to be the 7th month, but then we included July and August for Julius and Augustus Caesar. So now that we've got July and August, it messes up the whole calendar, right? For octopus or octagon, right? So octa, right? So October used to be the 8th month. Nona is going to be 9, and Deca will be 10. Okay. All right. So with naming, right, it is as simple as just looking at your subscript. Okay. This is just covalent. So for covalent bonding, it's going to be carbon, because most atoms don't get a mono. You don't say monocarbon. Carbon, and then I see that 4, so I say tetra. And I don't say chlorine, I say chloride. Because if it's in a covalent bond, it's going to be chloride. Okay? Let's review Vesper models as well, right? Carbon's going to be in the middle. 1, 2, 3, 4. Tetrachloride, right? Cl4 means I have 4 of that atom. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And of course, you shouldn't do your lowest dot structures this way unless you have done it countless amount of times and you're super good at it, right? So, because I have 4 atoms around the carbon, this is going to be a tetrahedral. And although there is a polar pull, yes, towards chlorine, because it's getting pulled in 4 directions equally, this is going to be non-polar. Okay? All right. So N2O, right? 2 goes to bi. So y'all, it's been a long day. Your prefix for 2 is not going to be bi, it's going to be di. Okay, so Di. All right. It's going to be, that's why it's called carbon dioxide. So it's going to be di-nitrogen. And then because it's an oxygen, it does get a mono. Not monoxygen, it's monoxide. Okay, let's go in the other way. So for phosphorus trichloride, it doesn't give me any kind of prefix, so I know it's just going to be one. So it's phosphorus, and then chlorine is Cl, and then tri means 3, so trichloride. Okay, dinitrogen, so N2 pentoxide. Right, I'm not going to draw that structure or this structure because they're more complicated, but let's do phosphorus trichloride. So phosphorus is going to be 1, 2, 3, 4, 5. Chlorine, chlorine, chlorine. 2, 3, 4, 5. 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay? Because of this lone pair, it's going to be a trigonal, pyramidal, and it's going to be polar. All right.